zeros of polynomials. So this is a very easy review of what we did last year, or what you guys did last year, since I didn't have many of you. So we have a fundamental theorem of algebra. And the fundamental theorem of algebra says for every polynomial of degree n, you have at least one zero in the complex number system. For instance, if you have x to the fifth, how many zeros would that give you? 5. Now, does that mean that they're going to be real zeros? No, they're going to be what? At least complex. And what does complex mean? Real and imaginary. All right. Well, everything can be broken down in what's called a linear factorization. Okay. And what we did before, we did like x plus 2 and then like x plus 3 and so forth and so on. That was a linear factorization. Why is it linear? Because all these are what? A first power. All right, so everything can be broken down in linear factorization using the fundamental theorem of algebra. On this, if I have a first degree polynomial, like x minus 2, all right, well, how many zeros would that one give you? That would give you 1 0. Now, I got big beef with this. What did they do wrong? It's not an ordered pair. It's not an ordered pair. That's a line. So it really should be 2, 0. All right. And then if you have a second degree polynomial like this guy right here, how many zeros would you have? You'd have 2. All right. These are the exact same 2, but they really should be 3, 0. Now, if you have 2 of them, remember, what does it do graphically? It bounces there. All right. If you have a third degree Taylor or a third degree polynomial, how many zeros are you going to have? 3. Now, are all of them going to be real or rational? No, they're not all going to be real or rational. For instance, on this one, I get to x squared plus 4. Can you give me a real number out of x squared plus 4 when I set these things equal to 0? No. All right. And so that would actually end up being subtracting 4, square rooting it, plus or minus, so you'd end up getting a positive 2i and a negative 2i, true? Well, let's think about this one. What if I have x squared plus 16? What if I have that? How could I factor x squared plus 16? I could factor x squared minus 16 real easy, wouldn't I? All right, but x squared plus 16, what would that factor to? X plus 4i and x minus 4i. All right, now, are those real? No, but they are what? Complex. All right. Now, if I have a fourth degree, how many zeros am I going to have? I'm going to have at least 4 complex zeros. All right. Our rational zero test, otherwise known as our P's and our Q's. All right. This is the bulk of what we're going to be doing today. When I find P's and Q's, I'm finding possible rational zeros. All right. I'm finding possible rational zeros using my P's and Q's. Well, P's are the factors of my constant. And then Q's are my factor of my leading coefficients. Let's freestyle one. So let's say if I have f of x is equal to, 2x cubed minus 8x plus 6. Why not? All right. My P's would be my factors of my constant term. So how would I get to 6? What are the factors of 6? 1 and 6. Good. What else? 2 and 3. What else? Okay, you could go backwards. You could do 6 and 1. But what about like -1 and -6? Wouldn't that also work to give me 6? Yeah. All right, so when we do these, you're going to have like plus or minus going on. All right. And then I do my Q's. And Q's are my factors of my leading coefficient. So what is my leading coefficient here? 2. My leading coefficient's 2. All right. So my Q's, how do I get to 2? 1 and 2. All right. It really is plus or minus. Totally true. However, I don't need both of them to be plus or minus because a negative over negative is again a what? A positive. And a positive over a negative or whatever is a negative. All right. So if I actually had to list out my P's and Q's on that, I would have 1 plus or minus 1, 2, 3, 6. But then what else would I have to do? I would also have to divide everything by what? 2. And so when I divide everything by 2, I could have plus or minus 1/2, or plus or minus 1, or plus or minus 3/2, or plus or minus 3. However, why didn't I write my 1 and 3? Because I already had it. All right. So how many possible rational zeros does this one have? 12. It actually has 12 because of the plus or minus going on. How many does it actually going to have? Possibly up to 3. All right. But I have 12 options to get to those 3. All right. Does that make sense? All right. So I'm going to find the rational zeros of this one. I have x cubed plus x plus 1. All right. So before we do anything, we need to find our p's and our q's. So how do I find my p's? The factors of my constant term. What are my factors of my constant term? 1 and 1, right? So plus or minus 1. Over my q's of what? My factors of my leading coefficient. All right? So it's still what? Plus or minus 1. All right? So I need a 1. We're going to do synthetic. So I have a 1. And then what do I need next? A 0. Why do I need a 0? Because there is no x squared. And then I'm going to have a 1 and a 1. What do I want my remainder to be? I want my remainder to be 0. All right? So what do you want to test? 1 or negative 1? 1. Let's test it. So if I test 1, I drop 1. And then I get 1. And then I get 1. And then I get... And then I get 2, and then I get 2, and then I get 3. So was that a 0? No, it wasn't a 0. So we're going to do it again. Now, normally I would erase, but in this one example, I'm going to keep it. All right, just to show you something. So now I'm going to choose what to test? Negative 1. So I'm going to drop my 1, and then I get negative 1, and then I get... And then I get, and then I get, and then I get, and then I get negative 1. So what did that tell us? Neither one of them work, right? So what did that tell us? No rational zeros. I have no rational zeros. Does that mean I don't have any zeros at all? That doesn't mean that. Because where does an x cubed start? A positive x cubed, where does it start? It starts down. Where's it going to end? Up. So where does it have to cross? It has to cross the x-axis. All right, it has to cross it. But I said no rational zeros. Well, I have a daggone 0, true? But it's not rational. What does it mean to be rational? A real number, okay. This is still a real number. Not a whole number, but a number that can be a fraction. A rational number is something that terminates or repeats, all right? Which basically means it can be a fraction, all right? So it doesn't have a rational. So now I have x to the 4th minus x cubed plus x squared minus 3x minus 6. And before I do anything, I need to find my p's and my q's. How do I find p's? The factors of my constant. So what are my factors of my constant? 1 and 6. What else? And 2 and 3. All right. What are my q's? 1, right? So that's really nice. So how many options do I have? I have 8 options. All right. So that's not too bad. That's really not that much. So now we're just going to start making our synthetic. So I'd have a 1 for my positive x to the 4th, a negative 1 for my x cubed, a positive 1 for my x squared, a negative 3, and a negative 6. What do we want our remainder to be? 0. We want it to be 0. Now, this is where I would ask you to write lightly with a pencil. It's probably going to be your best bet instead of redoing them all the time. All right? All right, what do we want to try? You want to try 1? Let's try 1. So if I get 1, I get 1, and then I get 0, and then I get, then I get, then I get, then I get, then I get. Is it going to work? No. So we're going to try it again. Is this coming back to you guys yet? All right, I would highly suggest you guys keep a bank of what you guys just used. So we just used 1, right? The sad thing is when I see students that try these over and over, and then they start trying the same thing, and it's just like, oh, that's sad. All right, so keep a bank of what you're using. It's going to make your life a little easier. All right, now what do we want to try? Negative 1? All right, let's try it. So then I get negative 1, and then I get negative 2, and then I get 2, and then I get 3, and then I get, and then I get, and then I get, and then I get, whoop, whoop. Did we win? We won. So right now, I would have negative 1, comma, 0, all right, as one of my zeros. And really what had happened was I actually end up having x plus 1, and then I end up having, this is my constant, this is my x, this is my x squared, this is my x cubed. So then I actually have x cubed minus 2x squared plus 3x minus 6. That's really what we just did, all right? However, I usually like to go to until I get a quadratic, because do we know how to F up quadratics quite well? Yeah, we sure do. All right, so let's do it again. So we know negative 1 works. All right, what do you want to try now? What do you want to try? 2? All right, let's try 2. So then I get, what did I just put a 2 there for? That's a 1. All right, so then I get a 2, and then a 0, and then a 3, and then a, look at that. So what do we know? 2 worked. So now I end up having 2, comma 0 as one of my rational zeros. All right, here we go. So then I end up having x plus 1, and then that would actually be x minus 2. And then what's this part? This 103 thing, that actually is what? X squared plus 3. Now, what's this one asking for? Find all the rational zeros. Is this going to give me a rational 0? That is not going to give me a rational 0, so I'm kind of done right there. Okay? So I actually only have how many rational zeros? 2. How many could I have? I could have 4 because it's a 4th degree. All right? Now, I'm actually going to go a little further. If it just said find all the zeros, I would set that equal to 0, true? So then I'd say x squared is equal to negative 3, right? And then how do I solve for x? I square root it. But when I square root it, I get what? Plus or minus I square root 3. And so I'd end up having I square root 3, comma 0, and negative I square root 3, comma 0. So if it said all zeros, I would include those two as well. All right. And there you go.